Welcome to question 1 of the 2017 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 1, for part A we have let the function f have a domain of -2 to infinity, where the rule is f of x equals x divided by x plus 2. And we are asked to differentiate f with respect to x. So to differentiate this, we can see that this would require the quotient rule. And in order to apply the quotient rule, we'll let the function in the numerator be u, so u is equal to x, and then v is going to equal the denominator x plus 2. Next up, we need to calculate du dx. So du dx is simply 1, and we also need to calculate dv dx. And the derivative of x plus 2 is also just 1. So from our formula sheet we can see that the derivative of a function u divided by v is equal to v times du dx minus u times dv dx, all divided by v squared. So therefore the derivative f dashed of x, which is what this question asks for, is equal to v, which had a rule x plus 2, and we'll need a bracket around that, times du dx, which is simply 1, minus u, which was x, times dv dx, which was 1. And all of that is divided by v squared, which is x plus 2, all squared. And now that expression for the derivative can be easily simplified, so we're going to do that for this question. So therefore f dashed of x is going to equal, and on the top line we would just have x plus 2 subtract x, which would just leave 2, and that is divided by x plus 2 all squared. So that is the derivative of f with respect to x, which is the answer to part A of this question. From the examiner's report we can see that 69% of students got full marks for that question, and overall the examiner said that this question was handled well. Students choosing the quotient rule tended to progress better than those who used the product rule, and it is possible to use the product rule for that question, but it looks like the quotient rule was the better option to take. And the examiner also notes that some very poor algebraic slips were made along the way. The most common of these slips was cancelling the x plus 2 in the numerator with the x plus 2 in the denominator. However, unless it's a common factor, it can't be cancelled. Others unnecessarily expanded the x plus 2 all squared on the bottom line and did so incorrectly, which would have caused them to lose a mark. For part B of this question we have the function g of x with the rule 2 subtract x cubed all cubed, and we're asked to evaluate g dash, the derivative, when x is 1. So first of all we can inspect this function and see that it's a function inside a function, so we're going to need to use the chain rule. And to apply the chain rule we first need to identify the outer function, which is something cubed, so we're going to write this as u cubed, where u, the inner function, is 2 subtract x cubed. So therefore y du, so the derivative of u cubed with respect to u, is just 3u squared, and du dx, the derivative of 2 subtract x cubed, is simply negative 3x squared. So from the formula sheet we know that the chain rule, which calculates dy dx, is equal to dy du multiplied by du dx. So therefore g dashed of x, just the derivative to start with, is simply equal to 3u squared times negative 3x squared. So 3, but u has a rule 2 subtract x cubed, so 3u squared is this term here, and we multiply that by negative 3x squared. And now we'll just do a tiny bit of simplification before we substitute 1 in. And we're just going to turn this into 3 times negative 3 is negative 9, and that x squared I'm going to write at the front, and then we still have 2 minus x cubed all squared. Next we need to evaluate the derivative when x is 1, so this is going to equal negative 9 times 1 squared is just negative 9, and then that's going to multiply 2 subtract 1 cubed is just 2 subtract 1, and then that is squared. 2 subtract 1 is 1, 1 squared is 1, which just leaves us with negative 9 times 1, which is simply negative 9. So that's the answer to part B of this question. So from the examiner's report, we can see that 2/3 of students got this correct, and the students were seen to competently apply the chain rule in this question. However, some did make errors with the derivative of 2 subtract x cubed to the power of 3, especially with the negative signs that were involved. Some students opted unnecessarily to take the longer route by often incorrectly expanding the rule given by g. Others forgot to evaluate g dashed of 1, which is a very important thing, as that was the instruction for the question.